Okay, electroplating. Now, you've probably heard this word before, but now being a top chemist in year 10, then you'll realize that it's something to do with electricity and electrolysis, and plating because it's about thin layers of metal. So essentially what we're doing here is we put in a thin layer of one metal on top of another metal. But why? Why would we do something like that? Well, there are essentially two reasons why we electroplate metals. We want to protect the metal that's underneath, the base metal, from corrosion. And this is usually iron or steel, because iron and steel suffer from rusting, they suffer from corrosion. So we protect them by putting a layer of another metal on top that stops them from corroding. It stops them from reacting with water and oxygen in the atmosphere. Okay, so that's logical. The second reason is to improve the appearance of the metal. So if we can have cheap metal, then we can cover it with a thin coat of attractive metal and we make the thing look nicer. There's also a cost dimension there. Instead of making a complete gold bracelet, we could take some steel, some stainless steel, and we could coat it with a thin layer of gold or silver, and it would cost a lot less to make, but it would appear to be a gold bracelet. Okay, those are the basic ideas. What metal do we usually make as the coat in electroplating? Typically it can be chromium, nickel, copper, silver, tin, and perhaps gold. Okay, so the outer layer can be one of those metals and others, but those are the typical ones. Now let's have a look at electroplating with copper. So this looks a little bit like the purification of copper, and it is. It is, because in this case we make the anode, we make it the copper metal that we want to use to electroplate something. Okay, and we make the cathode the object that we want to electroplate. So here at the anode, the copper, it's an active anode, active electrode. The copper goes into solution as it did with the purification of copper. And it looks like that. The copper atoms lose electrons, they lose 2 electrons and they go into solution. At the cathode, the copper ions in solution gain electrons through the key, through the cathode, and they become copper metal. And a thin layer of copper metal is deposited. Okay, the longer you leave it, the thicker the layer. And there are questions of current, how much electricity you use, and how long you leave it. If you want it to be a good layer, then you don't want it to be too thick because it can flake off. So it's getting all of those questions right before you start the process. Okay, so copper is deposited on the cathode. General conditions for electroplating. The object to be coated is the cathode, whatever it is. The metal that is being used to coat is the anode. So whatever we want to coat, we make that the anode. And the electrolyte is a solution of the metal being used to coat. So in this case, it could be copper nitrate or copper sulfate solution. Okay? They're the 3 conditions. Let's look at another example. The example of using silver to electroplate. So what have we got? We've got silver as the anode, and we've got a spoon as the cathode, and we've got silver nitrate solution. So that follows the rules, doesn't it? The metal that we want to use for coating is the anode. The solution is a soluble salt of the metal we're using to coat, and the object is the cathode. So let's have a look at the equations here. At the anode, the silver goes into solution, so it loses, or every silver atom loses an electron. And at the cathode, the silver regains that electron to deposit silver metal. Okay, nice and simple. In that way you save money, you make it look nice, and also, in this case, if it's a silver spoon, if it's a spoon made of iron, then you've coated the iron with silver, and that resists corrosion, it resists rusting. Right, have a think about that, read these pages and try the questions.